This is lesson 1.2, Rational Numbers in Decimal Form, part 2, which is about multiplying and dividing. So we have our sign rules. If we have two positive numbers that are being multiplied or divided, then your final answer is going to be positive. If you have one positive number and one negative number, then your final answer is going to be negative, because that individual negative sign is always going to overrule the positive one. If you have two negative numbers that are being multiplied or divided, then overall your final answer is going to be positive, because a double negative gives you a positive number. So two quick examples here. 4 times -3 gives you -12, but -4 times -3 gives you positive 12, because this double negative here cancels out to give you a positive overall. So how do we multiply with decimals? Hopefully you remember how to do long multiplication by hand. And the good news is we just do the exact same thing. We do long multiplication like normal, and we can ignore the decimal places for now. So if we had, let's say, 1.75, you basically just turn that into 175 and completely ignore the decimal at the beginning. For your final answer, you have to put the decimal places back in. So if you were multiplying 1.75 times 2.3, in these original numbers being multiplied, you add up how many decimal places exist. So we've got 1, 2, and 3 of them. That means your final answer is going to have 3 decimal places. So if your final answer was this, then you know you have to put the decimal place here, because it has to have 3 decimal places, because there's a total of 3 in your original question. And then finally, you just have to check that your sign is correct using the sign rules that we just talked about up here. I've linked 2 helpful resources about generally like a reminder of how to do long multiplication, and another link about multiplying with decimals if you want to check that out. So we have 2 examples. So the first step, we're going to basically remove the decimals, ignore them. So this will actually be 27 times 35. For now, I'm going to also ignore the negative sign and put that sign in at the end, just to make my life a little easier. So now I can do long multiplication like normal. So we've got 7 times 5 gives us 35, carry the 3. 5 times 2 is 10, plus 3 gives us 13. And then the second row, we're going to have a 0 at the start. And then 3 times 7 gives us 21, carry the 2. 3 times 2 is 6, plus 2 is 8. Then we add these lines up. We've got 5 and 4 and 9. And then we ask ourselves, where do we place the decimal? Well, in our original question, we have 1, 2 decimal places. So this is going to have 2 decimal places. So our final answer is 9.45. There you go. But I forgot, we have to make sure that our sign is correct. That's the last step. Since we had 1 positive and 1 negative, then that means that our final answer is going to be negative 9.45. There you go. Okay, we'll try one more. So at the beginning, I'm going to ignore the decimals. I'm going to ignore the negative signs. So this is actually 167 times 42. So that gives us 14, carry the 1. 6 times 2 is 12, plus 1 is 13. 2 times 1 is 2, plus 1 is 3. Next line, we've got our 0. And then 4 times 7 is 28. Carry this. That's going to give us 24, plus 4 is another 28. And this gives us 4 plus 2 is 6. Then we add these up. So we've got 4, we've got 11, we've got 12, and 7. Then we count how many decimal places originally existed. There was 1, 2, 3, 4. So this is going to have 4 decimal places. There's only 4 numbers, which means that the answer must be 0.7214, because it has to have 4 decimal places. Lastly, we make sure our sign is correct. We have a double negative, so overall our answer is going to be positive. So this is our final answer. Again, you have to do this without a calculator, but you can always check your work using one. Okay, next we're going to talk about how to divide when we're dealing with decimals. So again, hopefully you know how to do long division without decimals, because it's similar to what we did with multiplication. We're going to do long division like normal, except you're going to move around the decimal places at the beginning to account for them. So I'll show you I'll do an example as I explain these steps, and there are some more helpful resources here if you want to click them to learn more about how to do long division. So do long division like normal, except move the decimal places to the right until the number on the outside, or the divisor, doesn't have any decimal places. So for this first example, negative 6.85 divided by 0.5. So if we set this up, it would look like this. Again, I'm going to ignore the signs for now and put them in after. So we want to move the decimal places to the right until the number on the outside, this one, the divisor, doesn't have any decimals. So if we move this decimal over 1, then we would have 5. We have to do the same thing with the number on the inside, so that'll become 68.5. So we just have moved this decimal place over 1 for each, and we do that continuously until the number on the outside here no longer has any decimals in it, which we have achieved by moving it once. So now we're going to do this division question. And the step 2 here is if a decimal remains in the number under the divide sign, the dividend, so this number here, then carry that decimal up to your answer. So this decimal point is going to exist here in our final answer. Now we can do our long division like normal. So does 5 go into 6? How many times? It goes in once. So we've got 1, we carry the 8 down. How many times does 5 go into 18? Well, it's going to go in 3 times. And then 5 times 3 is 15. Leaves us with 3. Carry the 5 down. We've got a nice easy answer. 5 into 35 is 7. And that's our final answer there, 13.7. The decimals are already dealt with because we brought the decimal point up. Lastly, we have to make sure that our sign is correct. So since we had 1 negative and 1 positive, overall the answer is going to be negative. So negative 13.7 would be our answer. Okay, another example here. We've got same thing, 25.85 divided by 5.5. So this goes on the outside. We need to move our decimals to the right until the number on the outside no longer has any decimals in it. So we would just have to do 1 movement over because then we'd be left with 55. So we've got 55 and this becomes 258.5. It's okay if there's decimals here, there just can't be any decimals here. We bring this decimal place up for our final answer, and then we can do our long division. So does 55 go into 25? No. Does 55 go into 258? Well, we definitely goes into there. We just have to figure out how many times. So if you had a calculator with you, and you calculated 258 divided by 55, you would get 4.69. So you know it goes in 4 plus a little bit. If you don't have your calculator with you, one method you could try is you say 55 plus 55. What does that give me? It gives me 110. Okay, if I add another 55, what does that give me? That gives me 165. And you can continue in this method until you get the number that you need, and you can count how many times it's going in. So we know it goes in 4 times. 55 times 4 is going to give us 220. When we subtract those, it leaves us with 38. And then we bring our 5 down. Same thing, it's a pretty big number, so it's a little trickier. How many times does 55 go into 385? If you have your calculator with you, you can find out that it is exactly 7. But if you don't have your calculator, then you can just add 55s together until you get to 385. This goes in 7 times. We have no remainders left over. Lastly, we check our signs. These are both positive. So overall, our answer is going to be positive. And we've got exactly 4.7. If you struggle to remember the steps for long multiplication or long division, because I know it can be complicated, then you can try just estimating. This is similar to estimating with addition and subtraction. So you're just going to round your numbers to the closest integer and multiply or divide as usual. So I have 2 examples here for multiplication. 4.1 times 3.2, I round both those down because 1 and 2 are on the lower side. We get 12, and it's fairly close to the real answer of 13.12. This example here, same idea. I rounded this one down, I rounded this one up. Got negative 42 because I've got 7 times negative 6, and this is pretty close to our real answer of 40.32. So it's really easy and quick to estimate, and then you have a general idea of what your answer might be close to. It can be a little trickier to estimate when you're dealing with division. So for this example, we've got 44.6 or negative divided by negative 6.3. So I rounded this one up to 45 and I rounded this one down to 6. But then you have to ask yourselves, well, what is 45 divided by 6? That doesn't give you an answer that's really easy to work with right away. So I've written this side note here about a possible way to think through this. So we don't know what 45 divided by 6 is. We do know that 45 divided by 5 gives us 9. And so since we're actually asking for 46 divided by 5, or sorry, since we're actually looking for 45 divided by 6, and 6 is bigger than 5, you know that our answer is going to be slightly smaller than 9. Because if you're dividing by more than 5, it's going to be a smaller number than this. So we already have our upper range, it'll be less than 9. And then another thing to think about is, well, we know that 6 times 7 gives us 42, and 6 times 8 gives us 48. So it's going to be somewhere between 7 and 8 is going to give us this 45 in the middle. And it works out actually that 45 is exactly in the middle of 42 and 48, which means that our answer should be exactly between 7 and 8. So 7.5 would be a good estimate for this. So we've got 7.5, and this is positive because these two are negative. 7.5 is our estimate, and the real answer is actually 7.08. Of course, it's not going to be exact because we've done rounding, but it's pretty close. So we're just ending with knowing that estimating is a really, really useful skill to have. You'll be tested on your ability to estimate reasonably and to explain and show how you got your estimate. So that would be something like showing this thinking instead of just putting a random number.